Greetings of the day, student. I am Professor Nikita Chaksi and the topic is the sedimentation. In the last lecture, we have discussed the cage theory. We already discussed the batch sedimentation test basic experiment. We have discussed how the industrial thickener works, batch thickener as well as the continuous thickener. And today, based on that theory, we have to solve the following sum. Now, the sum given to us is now this is the data which is given to you. It is given that for the slurry containing 200 kg per meter cube, 200 kg solids per meter cube, right? So this is my C0 that is given to me. The data for the height and the time that is given to us in the data. Using the cage theory, you have to tabulate the sedimentation velocity and the solid flux. What area of the tank will be required to underflow concentration Cu? This is nothing but my Cu, concentration of the underflow that is given to you for the feed rate of 2 meter cube per minute. So this is my feed rate, that is Q0. Right. So to find out the area of the thickener, I require Q0, I require C0, I require Cu. Another thing that is required, that is the concentration at the each height and the settling velocity. So these two things I need to find out from the given set of the data. So first we need to plot the graph of the H versus T. Right. So this is the graph of the H versus T. Now once you plot the graph, you have on each point you have to draw the tangent. Then you have to take the slope of the tangent. See, I am using here touchpad, so my tangent is not clear, not correct. Actually, the tangent is means the line, you have to draw the line in such a way that it only crosses the curve at that point only. So draw the proper tangent, take the slope of the tangent, and that is nothing but your settling velocity at this height. So for all the points, you are supposed to draw the tangent, take the slope of the tangent and note down your settling velocity. The second thing which we require, we need to find out the concentration, right? So initial concentration, that is 200, that is given to us. Now we know the relation of the cage theory, that is what? C0 Z0, that is equal to Ci Zi, right? So this left side remains constant, C0 and Z0. My C0 is 200, Z0 is the 900 mm. So as I keep on changing this height, I am getting the different concentration. So substitute all the different values of Zi and find out all this concentration. So now by using the King's relation, you have the concentration at different height and you also have the velocity. The settling velocity is the slope of the tangent drawn to the curve at the different points. That is our settling velocity. So this which I have already explained to you, you have to use the King's relation and you have to find out the concentration. So as per my data, the values of the settling velocity at the different points are this. Now if you observe here, you should get the value in the decreasing order, because what we are assuming that as you move downward, we are getting near the equilibrium where our settling velocity approaches 0. So whatever the value you are getting here, maybe I am getting 13.4, maybe you are getting 15, 16, 20, whatever, but then after it should be in the decreasing order, right? So this is the data of the, this is the value of the settling velocity which you have to write from your graph. Now the solid flux, that is nothing but the volumetric flow rate divided by the area, the unit of which is kg per meter square into second. So in our case, if I want to find out the solid flux, that is multiplication of C into velocity. So we have the concentration at different height and again we have the settling velocity at the different height. So you can find out the solid flux. Now when you find out the solid flux, this is given in the kg per meter cube and your velocity, if you have not changed the data, then it is in mm per minute. So convert this in terms of the either keep in minute, keep it second and make it meter. Consistent the unit and finally you will get the answer. So accordingly, you have to find out the solid flux for all the data. So once you have the solid flux, the next is simple. This is Cu that is given to you, that is 1200 kg per meter cube. So for all the different values of C, substitute your value and find out this column. So here we are getting this value. Final 1 upon C minus 1 upon Cu divided by the settling velocity. And from this we have to select the highest value. Now this is what the unit of this is meter cube per kg divided by meter into second. So that is the kg per reciprocal of kg per meter square into second. So that is nothing but the solid handling capacity per unit area. So we are selecting the maximum value from here, that means whose solid handling capacity is minimum, and this value we are substituting in the formula of the thickener. So this is the formula of the thickener. We have the Q0, we have the C0, and this we have taken from the table whatever the maximum value we are getting. So we can substitute all the values and we are able to find out the area of the thickener. So in today's session we have to solve this problem. All of you keep graph paper with you. Thank you.